Hi guys, welcome back to the channel. Jag here. In today's class, we're going to continue with our Science 10 content, and we're just going to go over naming compounds. So with that, let's get started. All right, so here we are. Okay, so I put down naming compounds. Okay, and what we're going to go through is some of the regular binary compounds, which are ionic, as well as the polyatomic ions as well. Okay, so let's start with something simple. Okay, so say I have AgBr. Okay, and the question is just going to tell you to name the compound. Okay, so I'm just checking in the periodic table here. Ag is silver. If you're looking for Ag, it is in group 11. So I'm going to write silver. Okay, Br is bromine. Okay, this is group 17. But instead of writing bromine, we're just going to add the IDE at the end. Okay, so it becomes silver bromide. Okay, does everyone see that? Let's try one more on this side here. Say I have Li and then I like this. So now it is really important, okay, that you know all of these elements, especially maybe up to element 20, which is calcium. I should know what the symbols are. Okay, I should also make sure the spelling is correct as well. Okay, so if you look at Li is lithium. Okay, lithium is in group 1. Okay, and I is iodine. Again, it's in group 17. And we're going to add IDE at the end, okay? So basically it becomes iodide. So lithium iodide. Everyone's good? So let's go to the next type of naming for the compounds here. Okay, and what it's going to be is using the Roman numerals. Okay, and let's write it here. Okay, the reason I'm going to use Roman numerals is basically just for the transition metals. Okay, for the transition metals, they basically have more than one charge. And I do have to indicate the charge, okay, inside the brackets. All right, so let me pick an example here. Okay, so say I have, let's do something simple. So say I have CuO, okay, like this. And I'll show you both versions here. So Cu is copper. Now, if you look at copper, okay, copper is in group 11. Copper can actually have a charge of 1 plus or 2 plus. So maybe we'll write it here. I'll put 1 plus, 2 plus, okay? Oxygen has only one charge, which is 2 minus. Everyone see that? Okay, make sure you're using a periodic table that actually shows you the charges. Okay, so it's easier to take a look at that. Now, I noticed that there are no subscripts here beside the Cu or the O, okay, which means that the charges have to cancel out. Okay, so in this case, because oxygen is 2 minus, okay, I know that the copper has a charge of 2 plus. Does everyone see the reason for that? These two charges just cancel each other out, just like in math, okay? So say I'm naming this compound now, I'm going to put copper, brackets, okay? In Roman numerals, the 2 is basically just like 2 lines, like this. Okay, so it's going to be copper 2, and then oxide for oxygen. All right. And just like that, let's do the same example here, but say it's Cu, okay, and it's going to be 2 and O. Does everyone see? Okay, so this 2 with the subscript is actually coming from oxygen. I know oxygen is 2 minus, okay, and in this case, copper is actually 1 plus. Okay, if you use the crossover method, I noticed the 1 plus from the copper is actually just going to this side here. When there's no number beside the oxygen, it's assumed that oxygen, there's like 1 here. So it's like 1 atom of oxygen. Okay, so if I was to name this compound one more time, copper 1. Okay, like this in brackets, just like a line here. Oxide, okay? And that's how you name oxygen, okay? Oxygen just becomes oxide here. Okay, are there any questions? Okay, good. Let's try one more example here. I'm just going to write it going down. Okay, so let me pick one. Let's do PB 3 and N2. Okay, because Pb is used quite often. If you don't know what element that is, Pb is lead. Okay, lead is in group 14 here. Okay, lead can also have 2 charges. So I'm going to write the charges here. So 2 plus and 4 plus. Okay. Nitrogen has a charge of 3 minus. Okay. And again, just check the periodic table. You don't need to memorize these charges here. But I can see just by looking at it, okay, this 3 minus is actually coming from the nitrogen. And this 2 plus, so we're doing like a reverse crossover method. The 2 plus is coming, or the 2 comes from the lead here. So I'm just going to circle the charge. Okay, and in this case, if you had like a 4 here, the charge on the lead would actually be 4. Okay, so use the reverse crossover method like that, so you can just take a look. So let's name it. It's going to be lead and 2. Okay, so put the 2 in brackets. And the N is nitrogen. And so it becomes nitride. Okay, does everyone see that? So it's lead 2 nitride. Okay, so this is using the Roman numerals. And again, we're only using that when you have transition metals. And the transition metals have more than one charge. Okay, and that's the reason you're going to use it. Okay, are there any questions there? All right, so that looks good. Okay, so what we're going to move on to is going to be just naming, okay, for compounds that contain these polyatomic ions. All right, so let's write it on this side right here. Okay, so again, I should know some of these polyatomic ions, okay, and maybe just like the names of them. So I'm going to put maybe just a couple of them here. So OH, this is hydroxide. Okay. I would know CO3, the charge is 2 minus. This is carbonate. Okay, and all these polyatomic ions, I would actually make sure I memorize them. Okay, that way when you see it as you're naming compounds, okay, you recognize it faster. If I see PO4 by itself here, this is going to be phosphate. Okay. And let's do also SO4, which is 2 minus the charge here. This is sulfate. Okay, and I'm only naming the ones that are most commonly used. NO3 has a charge of 1 minus. This is nitrate. Okay. And I think I will also include HClO3 has a charge of 1 minus. Okay, actually, just put HCO3. Okay. This is bicarbonate. Okay. So you could put bicarbonate, okay, or also hydrogen carbonate. So both names are okay here. Okay, and I want to put down one more. ClO3 is very common. This is chlorate. Okay, so does everyone see that? And we will go through some trends, okay, maybe in the next video. So this video is just going to cover how to name these compounds using polyatomic ions as well. Okay, so with that, let's try just a couple of examples here, okay? So let's write it on the other paper. So let's try an example, okay? So I'm going to choose a compound here. So say I have CaCO3, which is actually a common compound that is used. So I know Ca is calcium. Okay, and now I see CO3, so I should recognize that it is polyatomic. And this is carbonate. Does everyone see that? Okay, so just like that, calcium, carbonate. Okay, so when you're naming the compounds, I don't have to worry too much, okay, about the subscripts that I see here. Okay, we're just naming it as we see it. Okay, so let's try one more here. Okay, I'm trying to choose one that we haven't done. Okay, so let's do Na and then HCO3. Okay. And there's so many different rules for naming, okay, these compounds. I want to make sure we cover a good portion of them. Okay, so NaHCO3, this is Na is sodium. Okay, and then HCO3, this is carbonate. Oh, sorry, so bicarbonate, okay? Okay, or I can also put sodium hydrogen carbonate. Okay, so that's all right as well. Okay, let's go down actually, okay, with each of these compounds. So say I have, so we can see just like a variety of these different compounds. So I have SC, OH3, okay? So if I look at SC, SC is actually scandium. Okay, now if you look over here, okay, even if I don't know what the charge is for scandium and I don't want to actually look at the periodic table, okay, or maybe the periodic table didn't indicate the actual charge, I can just do the reverse crossover method, okay? So this 3 is actually coming from the scandium. Okay, so I know scandium has a charge of 3 plus here. So we're going to put it in brackets with our Roman numerals. Okay, and if you see OH, just like we had in our list there, okay, OH is hydroxide. So it's basically going to be scandium 3 hydroxide, okay? Everyone see that? Okay, if there's a compound we didn't write down in our list, I'm just going to add it in here as we're going down. Okay, make sure you add it to your list as well, okay, in your notes. Okay, let's try the next one here. So this is V2, and then SO4 and 3, okay? So we're covering some of these elements, okay, that you might not be familiar with. Okay, V is vanadium. Okay, so if you look at vanadium, I see this 3 is coming from the vanadium, and the 2 is actually coming from the sulfate. Okay, does everyone see that? So I'm going to write it in brackets. It's going to be vanadium, brackets like 3, SO4, okay, which is sulfate. Okay, so it becomes vanadium 3 sulfate, okay? So I want to write this compound down here. Let's move on. This is a common compound actually. Make sure you add it in your notes as well. So it's NH4F, okay? So if I see NH4, the charge on NH4 is actually 1 plus, and I know fluorine has a charge of 1 minus, okay? And that's why you see that there are no subscripts here. The two charges just cancel each other out. NH4 is ammonium. Okay, and then F here is just fluorine. Okay, so I'm just going to put fluoride. Very good. So ammonium is actually one of the polyatomic ions. I would make sure I do memorize that. Okay, let's go down. So let's try another one with the transition metal. So it's going to be NiPO4. Okay. So same thing with nickel here. Okay, so nickel does have a couple of charges. Nickel can be, maybe we'll write it on top. Okay, it can be 2 plus, it can be 3 plus. Okay, and you can again just check the periodic table, okay, for what the charge is. PO4 I know is 3 minus. Okay, so again here I notice there are no subscripts. So in most cases, or in all the cases, okay, when you don't see a subscript like this, I know that the charge on nickel is 3 in this case, okay? And that's why the 3 plus and the 3 minus are just canceling out here. So we're going to write it out. So nickel, the charge on nickel is 3 plus. So nickel 3 and PO4. PO4 is just phosphate. Okay, everyone's good with that? All right, good. Okay, I want to show you this one compound. Okay, the reason for this, okay, is basically, I notice, so this is Li2, okay, SO3. Okay, now I notice it's not SO4, okay? SO4 is actually sulfate. If you remove one of the oxygens, in this case, how it becomes SO3, it becomes sulfite, okay? So Li is lithium, okay? And then SO3, not sulfate, but sulfite, okay? And basically, I'm just changing the ending over here from ATE to ITE. Okay, and you always do that when you remove one oxygen. Okay, and this is not just the case for sulfate. You can actually apply it to the other polyatomic ions as well. Okay, so anytime you remove one oxygen atom, it just becomes ITE in terms of the ending. Okay, does everyone see that? Okay, so I'm going to write one more compound. Okay, this one might be used in the lab, okay, quite often because it is an acid. It's actually like a weak acid. So I'm going to write it here. So it's SR, okay, C2, H3, and O2, okay, brackets, 2, okay. So this is actually the compound here, okay. It's C2H3 and O2. It's known as acetate, okay. So SR here is strontium, okay, like this, okay. So again, strontium is actually in group 2, okay. I notice I don't need to use the Roman numerals here because strontium only has one charge, okay. It is 2+. So this is going to be strontium and then acetate. Okay, so just like this. Okay, so strontium has a charge of 2+. Acetate has a charge of 1-. Okay, and you notice we just crossed it over here. Okay, to the opposite side using the crossover method. Okay, and that's where the subscripts are coming from. All right. Okay, so that looks good. And if there are no questions, that does bring this video to an end. Thank you so much for watching. Please make sure you do like, share, and subscribe to the channel, and I will see everyone in the next video. Thanks. Bye.